Good morning, everybody. We just talked about energy, and now we're going to talk about pie charts, which is a way to keep track of the energy. So, um, first, we're going to draw an interaction diagram. And what are we interested in? This ball is held above the ground and then it drops straight down. So, the ball is important, but the ball is interacting with the earth. And we talked about how that interaction gives you gravitational potential energy. So I think both of these things are important. So I'm going to draw the dotted line around both of them. So both the ball and the earth is my system. That's what I'm interested in. So what I do is I go through the different types of energy and I see if it's there. Well, at the first position, right up here, is it moving? No, that's what that dot means. It's not moving. So there's no kinetic and there's nothing being deformed, but there is an interaction between the ball and the earth earth is above, or the ball is above y=0, which I'm going to say is right there at the ground. So this first pi has only gravitational potential energy. Okay, at the next spot, it is moving, and it's not really even halfway down. So it's moving, so there's kinetic energy, and it's above y=0, so there's still gravitational potential energy. So I'm going to make my pie, the slices of my pie look like that. All right? It isn't that important what they actually look like, just as long as they change in the right direction. So I have more gravitational because it's not even halfway down, and then I have kinetic energy. Then at the last place, it's right before it hits the ground, right before it hits the ground, the instant before it hits the ground. And so I'm going to say it has all kinetic energy. The instant before it hits the ground, that gravitational potential energy is just too small. We can ignore that. And some of you might be saying, well, what about air resistance? Well, we're going to ignore air resistance because the ball is held just above the ground, okay? It's not that far above the ground. So we ignored air resistance. So this is my pie chart. I can say all of the gravitational energy was in the gravitational field was transferred to gravitational energy in the field, and kinetic energy stored in the object, in the ball, and that was transferred to all kinetic energy stored in the ball. And all the pies have the same size pies, because no energy went into or out of the system. Okay, that's one example. Another example I have now is a ball is held at the top of a tall building. That means I can't ignore air resistance. So my interaction diagram is I have a ball and the earth. They're interacting with the force of gravity. But now I have to think about the air, right? And that would be a frictional force. And since I think all those things are important, I'm going to put all of them in my system. So let's do the pies. Well, it's the same to begin with. It's all gravitational energy stored in the gravitational field. I still have the same amount of gravitational energy, but it might be moving just a little bit slower because now I have air resistance. And the way I denote dissipated energy, or E-dis, is I shade it in just to make it different. E-dis is a special kind of energy. It can't be turned into another kind of energy. Once it's E-dis, the slice of the pie can only stay the same or get bigger. And then at the very end, I do have kinetic energy, and I have a little bit more E-dis. So I could say my gravitational energy stored in the gravitational field. I'll write that so you can read it. Stored in the gravitational field was transferred to, was transferred to gravitational energy stored in the gravitational field, kinetic energy stored in the ball, and dissipated energy stored somewhere in my system. It could be in the ball, it could be in the air. That was then transferred to kinetic energy stored in my ball and E-dis, again stored somewhere in my system. And again, all the pies are the same size because no energy has gone into or out of the system. So that is a way to keep track of energy, and it is called pie charts. Have a great day.